So video's jumping in a little late, but this is just review. So yes, cosecant is reciprocal partners with sine. It's the flip of sine. So, Ian, what's the sine of 5 pi over 6? One half. And it's in the second quadrant, so the y-coordinate is positive. So it's a positive 1/2. Well, the sine is 1/2. But then when we flip it over, what's the flip of 1/2? That's an easy one to flip, 2. Cotangent. Do I really want to do all of these? No. Nor do you. Let's do through 12, and we'll see if that's enough. Cotangent. You do the next. You to try these. Watch me do them. So do through 12, and then we'll move on to the next stuff. Well, there are two types of lessons, like functions we need to know how to take a derivative of, and then using those derivatives, and we kind of go back and forth. Obviously, today is just we need to learn how to take derivatives of trig functions, and then we don't really use them a whole lot today, except find the slope of the tangent line, find the instantaneous rate of change. So today we're adding this to our list of things that we know the derivative of. All right, you have to memorize these. The good news is they're very much related to each other. So once you get 3 of them, you'll definitely get the other side. Derivative of sine is cosine. Which again, that's kind of weird how it works. That means if you're on the sine graph, the slope of any spot on the sine graph is the cosine of that spot. It's kind of weird how that works. Derivative of tangent, now things get a little more complicated, is secant squared. Derivative of tangent is secant squared. Derivative of secant is secant tangent. Okay, now the other 3. Good news is they're very much related to the first 3. Derivative of cosine is not sine, that'd be nice, but it's negative sine. derivative of cotangent. So you've only done one of these, so noticing a pattern is kind of tricky when you've only got one to look at. But based on the first set of answers, do you care to take a guess on what the derivative of cotangent is? Okay, cosecant squared, and it's negative. Care to take a guess on what the derivative of cosecant is based on the derivative of secant and the patterns that are happening so far? Negative cosecant cotangent. So you absolutely have to know all 6 of them, but really once you know 3 of them, you can sort of figure out the other 3. So definitely make sure you have those 3 memorized, plus those are more common. But if you have those memorized, then you can figure out the others without too much difficulty. Okay, some examples. Y equals 2 sine x. Then dy dx equals, well, the 2 can just kind of go along for the ride. And the derivative of sine is cosine. So yeah, that's it for number 1. Why don't you try number 2? You could put it over 3, but it needs to end up being positive because this minus. So you could do minus negative, and you can put it over 3. That's fine. Like minus negative cosecant squared. Whoops, cosecant squared of x over 3. You could write it like that. That would be okay. Again, you just got to know these. There's not really much magic or anything or tricks even. You just got to memorize those derivatives. Number 5, instantaneous rate of change. What's that code word for? Derivative. This is like almost everything. It's asking for a derivative. Instantaneous rate of change to f of x equals cosine minus tangent at pi over 3. So how is number 5 different than the previous 4? Yeah, it gives you a point you're going to have to plug in, or a value to plug in. So it starts out the same way. We'll just take the derivative of cosine is negative sine, and derivative of tangent is secant squared. And evaluate that at pi over 3. Kind of pains me to say this as a pre-cal teacher, as your pre-cal teacher, many of you, that is a safe stop because it is calculator ready and because there's no calculus left. So if you have a free response question and you make it that far, you can be good. Now it's probably going to be multiple choice, so you're going to need to know your unit circle, but it is a safe stop. So leaving trig functions, as long as you've plugged in there, the angle, you can leave that. Now I'm going to finish this problem because that annoys me to see that as a safe stop. Sine of pi over 3 is root 3 over 2. Secant of pi over 3, let's see, secant is flip of cosine. Cosine's 1/2, flip that over, I get 2. So negative root 3 over 2 minus 4. And again, something that's as straightforward as that question is probably going to be multiple choice, and you'll need to be able to simplify it to get the right answer. Number 6, find the slope of the line tangent to the curve. So what's this asking? How do we find the slope of a tangent line? Take the derivative. That's probably the answer to any question this this month, or this semester even. If the question is, how do we ... the answer is take a derivative. Probably usually followed up with do something with it, but it starts with take a derivative. So dy dx equals, I like the fractions out front, so I'm going to make that 1/4 cosine x. And then derivative of cotangent is negative, so minus 1/2 cosecant squared x. So I'm just switching up my notation here. 1/4 cosine pi over 6 minus 1/2 cosecant pi over 6 squared. You know what? Why don't you see if you can finish that out? Like, that's the safe stop. But let's see how our trig and our algebra work together to get an answer on that one. To get from safe stop to multiple choice, it's always previous year stuff, because that's what means it's a safe stop. There's no more calculus left. The rest is cleanup work. Number 8, find the f prime at pi over 6. So this is kind of a straightforward one. Derivative of secant is secant tangent at pi over 6. So let's see. Oops. I keep making this mistake, and I need to clean up my act on this kind of thing. What I've written isn't wrong, but what I've implied is f prime is equal to that, but f prime of x is not this. I need to say that this is f prime at pi over 6. And some of you missed points on the last test because it's not so much that you had was wrong, you just didn't have enough written down. You didn't label what you were doing. So, especially on a free response. Obviously, multiple choice, who cares? Show what you need to show to get the answer. But on a free response, I need you to show and label what you're doing. All right, secant goes with cosine. Cosine is the long side, so that would be 2 over root 3 when I flip it. Tangent 3 rule, root 3 over 3. And I mean, that's a safe stop, but it's also got an easy fix here. The root 3's cancel, and then 12 divided by 3 is 4. So all that to get a nice little answer. Let's skip 7 because it's the same thing. Take a derivative, plug in pi over 2. And that's it for today. So like it's a little deceiving. Like, the lesson's short. Like, my video is 13 minutes long. Like, what's the big deal? But the importance is not related to the length of the lesson, right? Like, you got to know this. Once you know it, it's not hard, but you got to know it. Today's assignment is whatever worksheet is next, which I think would be worksheet 4.